Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 14th, 2025, about 3 days ago. This paper introduces a system that boosts a model's performance on math benchmarks by over 5%, using just under 10,000 training samples. The paper is titled WeMath 2.0, a versatile math book system for incentivizing visual mathematical reasoning. And as we'll see, their approach to curating data and training is quite methodical. It's all about a unified framework combining a structured knowledge system and progressive reinforcement learning to teach models visual math. Also, the authors shared their work on GitHub. If you check it out, you'll find the complete code and data for WeMath 2.0. This includes, everything you need to replicate their training process, from the initial supervised fine-tuning to the progressive reinforcement learning steps. It's all laid out there. To put their contribution into context, this table compares their MathBook dataset with several other multimodal math datasets. You can see that most existing datasets are either for training or benchmarking and often rely on collected images. Looking at their own dataset, MathBook, it's designed for both training and benchmarking, and all images are manually created using GeoGebra for precision. And the real standout features are the annotations. It covers 491 knowledge points and has 8 distinct difficulty levels, which is far more comprehensive. Alright, so this diagram gives us a great visual overview of the whole MathBook system. At the very center, you can see the core of it all, 491 knowledge points and 819 fundamental principles. These are then organized into 5 major domains, things like geometry, algebra, and probability and statistics. The diagram then shows how these high-level concepts break down into more specific topics, and even provides example problems for each, showing the full hierarchy from abstract principles down to concrete questions. Building on that knowledge system, this figure illustrates the entire workflow, from data creation to training. The top panel outlines the training pipeline, which begins with an initial phase called Cold Start Fine-Tuning, or SFT, before moving into a 2-stage reinforcement learning process to progressively improve the model. The bottom half then shows the 2 datasets. On the left, MathBook-Standard creates variations from a seed problem, like asking multiple questions about a single image. On the right, MathBook-Pro systematically increases difficulty across 3 dimensions: step complexity, visual complexity, and contextual complexity. So, how does that whole system perform in practice? Well, this table shows the main results, comparing their model against both closed-source models like GPT-4o and other open-source ones. Their model, called MathBook-7b, is right at the bottom, and it achieves an average score of 48.7 across 4 different math benchmarks. This represents more than a 5% improvement over its base model, QN 2.5 VL7b, and what's really striking is that it achieves this with just 1K plus 9.8K training samples, much less than many competitors. Okay, so to really probe these models' limits, the team created their own benchmark, MathBook Eval. This table shows how different models stack up, and a couple of key trends jump out. First, looking at the reasoning section, performance for all models drops quite a bit as the problems require more steps, going from level 1 to level 3. Then, if you look at the knowledge categories, you see that models generally handle algebra well, but consistently struggle with geometry. Their own model, MathBook-7b, shows a similar pattern but remains very competitive. So to bring it all together, the WeMath 2.0 system really highlights the power of a knowledge-first approach. By structuring math concepts and using them to create progressively harder problems, they achieved impressive results with a remarkably small amount of training data. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.